Welcome to Cognira. Chapter 2, Core Data Platform Fundamentals. In 2026, while AI models get the headlines, the principal architect knows that the platform's ceiling is determined by its foundational rigor. Failure here isn't just a technical glitch. It is a structural collapse that invalidates all downstream AI intelligence. The OLTP versus OLAP boundary. Problem: resource contention and state mismatch between operations and analysis. Situation: many enterprises attempt to run complex AI feature extraction or heavy analytical queries directly against production transactional databases, OLTP. This either crashes production systems or results in dirty reads, where an AI model makes a decision based on an uncommitted or partially updated state. Task: guarantee complete isolation between stateful operations and longitudinal analysis while maintaining sub-second synchronization. Action: architecture: enforce a strict separation. OLTP, Postgres, or Spanner handles the now, while OLAP, Iceberg or Snowflake or BigQuery, handles the then. Synchronization: use log-based CDC, change data capture, rather than query-based polling to move data. Storage standard: standardize on open table formats, OTF, like Apache Iceberg. This allows multiple engines, Spark, Trino, Flink, to access the same data with ACID guarantees. Result: 0% performance impact on production applications. Time travel capability, allowing AI models to be trained on the exact state of the world as it existed at any historical timestamp. Normalization versus dimensional modeling. Problem: the flat table fallacy, trading structural integrity for perceived simplicity. Situation: the rise of one big table for big data has led to massive redundancy and update anomalies. When a product name changes, OBT requires updating millions of rows, or worse, results in an AI model seeing two different names for the same SKU, breaking entity resolution. Task: implement a multi-stage modeling strategy that balances storage efficiency with query performance. Action: integration layer, Silver use third normal form, 3 nanofarads, or Data Vault 2.0. This ensures single source of truth by removing redundancy. Presentation layer, Gold use dimensional modeling, star schema. Facts and dimensions make data intuitive for both BI tools and LLM agents to join and navigate. AI feature layer, materialize flat views only at the final step for model consumption to minimize token overhead. Result: 50% reduction in storage costs, 100% logic consistency across different business domains. The 6 dimensions of data quality. Problem: treating quality as a binary, good or bad, instead of a multidimensional metric. Situation: pipelines often report success simply because the data arrived. However, the data may be incomplete, null values, stale, 24 hours old, or invalid, negative prices. In an AI-native system, these silent failures lead to catastrophic model drift. Task: embed quality guardrails directly into the data plane. Action: implement automated testing for the 6 core dimensions. Accuracy: does data match the physical reality? Cross-reference sources. Completeness: are there unexpected nulls and mandatory fields? Consistency: does user ID in the sales table exist in the users table? Timeliness: is the data fresh according to the defined SLA? Validity: does the data follow the required format? Example: ISO 8601 for dates? Uniqueness: are there duplicate transactions? Result: automated data trust scores for every asset. AI agents can refuse to answer if the underlying data quality drops below a threshold. Data contracts, the API for data. Problem: the throw it over the wall mentality between app dev and data engineering. Situation: application developers frequently change database schemas to support new features, inadvertently breaking downstream AI pipelines. This producer-consumer decoupling is the #1 cause of data downtime. Task: establish a formal agreement between data producers and consumers. Action: contract definition. Use YAML or JSON schema to define the contract, fields, types, SLAs, semantics. Enforcement: integrate contract validation into the CI/CD pipeline. If a developer's PR breaks a contract, the build fails. Decoupling: producers provide data to a clean room or landing zone that adheres to the contract, regardless of their internal DB structure. Result: elimination of unexpected schema changes, 70% reduction in downstream pipeline failures. Schema evolution and versioning. Problem: the breaking change trap during system upgrades. Situation: enterprises often face a stop-the-world migration when a core data structure changes. Without a versioning strategy, you cannot support legacy models while transitioning to new ones. Task: support N1 compatibility for all data structures. Action: expansion and contraction pattern. 1. Add new fields, expansion. 2. Migrate consumers. 3. Remove old fields, contraction. Semantic versioning. Treat schemas like software, major, minor, patch. Virtualization. Use SQL views to provide a legacy view of the data even after the underlying table has been refactored. Result: zero downtime migrations, the ability to roll back AI models without rolling back the entire database. Thank you for listening. We will meet again in Chapter 3.